present value. Last week we covered future values. Today we're doing present values. So I'm gonna use the textbook, like I said, to explain. So a present value is essentially a formula used to calculate or deal with loans. Okay. So yeah, that's essentially that. You touched on it last year, but I'm gonna like explain it like explicitly so that you guys understand like to its like smallest to its smallest building blocks. I don't know if that makes sense, but I'm gonna break it down. So consider this scenario, ne? Consider this scenario. So this guy Tapelo has two different accounts with one bank. So this guy's got a Capitec. Okay, let me not say Capitec, but yeah, he's got a bank, and then under that bank, he's got two accounts: account one and account two. You guys know about that? You know that that is possible, right? Yes. Okay, sure. Sure, all of you have money, so yeah. So now, under account, look at what happens. Under account one, ne? Let's assume that okay, today is the beginning of 2021 or 2025, doesn't matter. Let's make it 2021 because it's easy to follow. At the beginning of the month, January 2021, ne? Tapelo borrows under account one. Don't forget, borrows 100 rands from the bank under account one and promises to pay the bank with interest at the end of the month. So obviously, when you take out a loan from a bank, you are expected to pay interest at the end of the term, however you pay. Okay. So now this guy at the beginning of January, let's just say the 1st of January 2021, just assume that's today. Ne? He borrows 100 rands from the bank and promises to pay at the end of the month, not at the end of the year. No. At the end of the month with interest. Okay, fair. Now the bank tells him the interest rate in the general banking environment or for that account is 60%. It's a high number, but I'm just using the 60% for the ease of our calculations. Okay. So the interest rate in the general banking environment is 60% per annum compounded monthly. All right. Fair. Now, you guys remember, those of you here last week, if you're not here last week, you've missed out on a lot of information. And then it pains me whenever I have to explain something I did last week. It's not nice. Neh? However, yeah, I'll just touch on it. So, do you guys remember what compounded monthly means? It means that when you put like an amount of money in a bank account, it grows how often? It grows after every month. So that's what compounded monthly means. It means grows per month. Okay, that's what it means. So, for example, I'll just give an example. This is the end of January, end of February, and so on. Someone invests, I'm just giving an example, 500 rands today under these conditions. It means that after a month, this 500 rands will gain interest because it says compound monthly. If it says compound quarterly, it means that after every 3 months, it gains interest. After every 3 months, it gains interest. Okay, but now let's just focus on this month one. So compound monthly means grows at the end of every month. So if you got a 500 rands there, after a month, it gains interest. After a month, it gains interest. But now, what interest does it gain? Does it gain 60% per annum? No. 60% per annum means per year. So you have to find a way, or rather, you have to find the interest with which it grows over a period of a month. How do you do that? Since 60% is for the whole year, you must divide it by 12 because you got 12 months in a year. Each month must have its own interest. So if you divide it by 12, this will give you an answer of 5%. So this means that this whole statement, 60% per annum compound monthly, it means that if you put in a 500 rands there, it'll get compound monthly means it'll gain interest after every month. But the interest don't be 60, it'll be 5%. Are we together? Yes? Proper stuff. Okay, fair. Yes. So this is just an example to explain what something like 6% per annum compound monthly means or quarterly or whatever it is. All right. So I just wanted to explain that. But what we are doing here, we started with a scenario here. Utapele two different accounts, and then under account one, this is what we have at the beginning of the month of January, or beginning of the month of January 2021. Let's just assume it's today. He borrows 100 rands from the bank and promises to pay interest at the end of the month. Okay, the interest rate is in the general banking environment 60% per annum compounded monthly. Okay, fair. How much will he pay to the bank at the end of the month? Okay, now we are going to draw a timeline because that gives us a clear picture of what's going on. I'm feeling cold. Let me just quickly get Just a second. Just a second. I'm gonna pause. Okay, thank you for your patience. So I was saying, we always draw a timeline because it gives us a clear picture of what's going on. So sometimes you may see it as something trivial, something small, but what happens is when you draw a timeline, your subconscious mind, your source of intelligence has something to work with. So when it sees something like this, it gets activated. It gives you ideas. Okay, so we're gonna draw a timeline for that. So remember at the beginning, which is time zero, beginning of the month times 0, and account 1, this guy borrows 100 rands, okay? And then at the end of the month, he promised to pay back the bank, okay? Obviously, he's going to pay it back with interest. What is the interest? We talk about this interest over here. Okay, fair. So, which means that at the end of the period, this guy will pay 100 rands plus that interest or whatever it is. Again, that's what it is essentially. Are we together? Yes, yes. Okay, let's push for it. So, we will then use our classical formula A equals P 1 plus I to the power N. Okay. So some of you might be confused, like, why is he using the investment formula if we're dealing with a loan? So look at it this way. This is super ultra fundamentally important. So whenever you're dealing with such questions or such scenarios, think of it this way. It's almost like the bank borrows money from Utapelo, right? Um, wait. I'm confusing it. The bank borrows money from Tapel. Yeah, okay, yeah, it's that way, yeah. So it's almost like the bank borrows money to Tapelo, ne? And then like the money gains interest. Does that make sense? Does that make sense? So it's like Utapel is a bank. Okay, I'll repeat. Utapel is like a bank. Utapel is a bank, ne? And the bank is like Utapel. So the bank is playing the role of like a person, a customer, while the bank is playing the role. Sorry, the bank is playing the role of a customer, ne? So think of the bank as a customer, while Utapel is the bank. So when the bank gives Tapel the 100 rand, it's almost like it is depositing money to a bank and then it gains interest. Hence, we use this formula. Does it now make sense? Yes. Sorry there. Couldn't articulate it. Fair. So now think of it that way. So that's why we use this formula, ne? So fair. So our principal amount will then be the $100. The $100. The interest. Remember, I told you already. Since this guy's gonna pay back the bank after a month, or rather, the bank will what's this? Withdraw its money from bank Tapelo. Tapelo Bank will draw the bank will draw its money from him after a month. It'll gain interest. Now, since it's after a month, the interest is gonna gain. It's not gonna be 60%. It's gonna be that 5% we calculated. You guys remember that? So we just go 60%. Okay, 60% is same as 60 over 100. You guys remember that I said this thing means over 100. So it gives you 0.6. And then after that, this is basically 60%. You split it 12 times, so you divide it by 12. So that's why I have 0.05 there. Happy? Bafwetu? Modimo ko mogolo wa kgalado. So yeah, we just substituted now n as 1 because that's the period with which the money grows. So it's 1 month. Okay. So here's a substitution, 100, 1 plus 0.0, we get 105. This then means that at the end of the month, at the end of the time, Otapelo will pay the bank 105 in total. That's basically 100 rands plus 5% to the bank. Does that make sense? Easy, ne? Yes. I'm building up something here. I'm building up something. Okay, fair. So now I'm gonna just redraw the timeline so that we have a clear picture. So this guy borrowed 100 rand, then paid back 105. Okay, but what if in an exam, they give you exactly the same scenario, but they tell you that okay, Utapela borrows a certain amount of money. They don't tell you how much, ne? They say he borrows a certain amount of money under under this investment environment, and then he pays back the bank after 1 month, pays back a total of 105. What was the loan amount? So this is how you're going to go about it. You're still going to use the same formula because nothing changes. The only thing that changes is that they didn't give you the principal amount, but they give you the final amount. So you're going to substitute A with 105 and obviously solve for P. This will eventually give us, let's solve it. So we're looking for P, so we're going to divide both sides by 1 plus 0.05 like this. Ne? Cancel what you do on the left, also do on the right. So this is what we have there. Okay, then I just put this P here and then this value on the other side. Ne? So then you guys know what A over B. You guys know A over B is the same as A times 1 over B. Do you guys know that? Yes. So this is exactly what I did here. So I just left the 105 there and then I just sort of split these two and put a times, put 1 over that value over there. So we're happy. And then by the laws of exponents, I'm going to apply this. Look, this is equal to that. So I'm going to apply that here. Remember, it means that a number, this means or translates 1 over a number to the power 1 is the same as that number to the power minus 1. So I'm going to apply this law of exponents on this. So here's my A. Then I'm going to go 1 plus 0.05 to the power minus 1. So then therefore I could replace this with that. So that's how I got that. Are we happy? Proper stuff. So and then when you punch this into a calculator, we get an answer of 100, which gives us the value, the loan amount that we initially had. So this just tells you really your calculation is correct. So this is a build up to the formula for present value. So I'm just showing you how they derived it using an example. So are we all happy with the original scenario and then taking out this 100 and then giving the 105 and then calculating the 100? Are we all happy with that? Proper stuff, proper stuff, proper stuff. Okay, fed. So we go down, and then I want you guys to notice something there on this line here, this thing here, ne? This expression. I'm gonna rewrite it there at the bottom, ne? And I want us to read the statement. Or let's read from here so that you guys see what's going on. It says, as before, 100 rands is the amount Tapelo borrowed under account 1 at the beginning. Okay, that's how we calculate it when we are given the amount he pays at the end. So that's literally what I just explained. That's how we calculate it. Okay, so to calculate the loan amount, you just simply take the future payment due to be paid, which is 105, and discount it to the beginning. So since we know what they didn't tell us this amount at the beginning, ne? But they tell us he's gonna pay this much under those investment conditions. So now, you're looking for the loan amount. So how you should look at it is that or how you should calculate it. You take the loan amount as simply the future payment due discounted back to the present day. So you take this future value, you bring it back to the present day. And how do you bring it back? You're going to use the interest in that environment, which is 0.05 or 5%. Then for how long, for how many periods do you take it back? 1 period. So that's why we have 105 and we discount it back to the present day. Do you guys see? If it has a time 2, we're going to discount it 2 periods so that it comes back to the present day. It's like you're doing the reverse of the original. Originally, we had 100, goes back into the future, gives us 105. So now you're doing the reverse, you're discounting back. Do you guys get it? Any questions? Okay, I'm going to touch on this just one more time. Initially, we had 100, took it to the future, from today, we got 105. We put 1 there. We have this 105. When I take it back, you put minus there. You're going back. That's what it is. So that's what it is there. And the textbook explains quite explicitly that the negative shows that we're discounting or counting backwards. Lamna, do you have a question, mate? Okay, proper stuff. Ah, 2 minutes here in full force. Okay, fair. Sharp. So yeah, so then I said basically the loan amount is discounted. Sorry, basically the loan amount is the discounted value of the payment in the future. So that's how you should always look at it. Then I just derived the Young formula. The loan amount is equal to future value, future payment 1 plus I to the power minus n, which is literally that. In our situation, we put 105, 1 plus 0.05, and then how many periods? 1. Ne? Easy peasy lemon squeezy. Okay. I'm gonna pause for 1 minute for you guys to digest everything that I've taught thus far, and then fire your questions, please. You look on for a re ke tloela Afrikaans ngwanake tlong go batša ngwanake e re ke e tlogele batho ba polokwane e re ke e tlogele o diang mona ai polepolela nka se e tlwaele nka se kgone o diang wena mona betha mona betha ai it's too much for me betha ai betha okay 30 seconds left. Fere, the whole congregation is happy. Yes, yay, we happy. Okay, Fere, all of this happened under account 1. All right? Remember this guy, Tapelo, yes, he banks with one bank, but he's got 2 different accounts. So what we've just done is under account 1. Okay? Keep this in mind, you'll use it soon. Okay. Let's see what happens on account 2. At the beginning of the month, January 2021, same beginning, whatever time, Tapele borrows 95.238089, this amount, from the bank and promises to pay with interest at the end of the second month. You guys remember, this is the beginning, January the 1st, 2021. Then he borrows this much, 95.23, and from the bank and promises to pay after 2 months. You guys remember on account 1, he borrowed 100 Rand CP. He promised to pay after 1 month. So we just only focused on account 2, but we're gonna put them together soon. So yeah, so that's what's going on in account 2, time 0, 1st of Jan, and then time 1, nothing happens. Time 2, he pays back the bank. He's obviously gonna pay them this amount plus interest. Fair. So how do we calculate that amount? How much is that amount? So we used our classical formula. Our P is the 95.23. Our interest, don't forget, is 5% or 0.05. And then our time is 2. The number of periods over which the money grows. It's 1, 2. We're working in terms of months, so it's 2 months, so it's 2. This is not the number of years. Be careful. Okay? 2. Fair? So we substitute there and we get an answer of 105. So it means that this guy will pay 105 at the end of the second month, as shown on the timeline. So remember, I borrowed the money here, 9.25. Then at time 2, it's going to pay 105. This happens under account 2. Happy? We all follow the story? Yavakala madoda. uNkulunkulu mkhulu madoda. Siyambonga. Ish. I was watching this thing, man. This what's this thing? This like show. It's a comedy. I don't know if you guys know the thingy, man. Emzini Zinsizwa. So it's a comedy. It's super ultra funny. But there's this other line from this other old man, Ori, but he speaks closer though. He said this line, it's like uThixo ondimthandazayo uva masinyane. Ori, uThixo ondimthandazayo uva masinyane. Yeah. Eish, that line touched me. Or modimo ke mo rapelang o kwa ka pele, o kwa ka speed. That line like hit me. But anyways, so you guys understand the story. So yeah, I'm soon gonna put the whole thing together. But let's just finish off with account 2. Let's just say in an exam, that's what I wrote there. They don't give you this amount. They tell you this guy is gonna pay 105 at the end of the second month under these investment conditions. these investment conditions. Okay, they tell you it's going to pay that 105, but they don't give you the initial value. How would you calculate it? You literally use the same formula, ne? But you're given A, which is 105. You're looking for P. So this is what we have there. We are looking for P. We have A, so we just substitute everything easy. Then like we make P the subject of the formula. For us to do that is to first, in order for us to do that, so first remove this by dividing by the same thing so they can cancel. What you do on one side, you do on the other. So that's exactly what I did here. They cancel, and I'm left with this. Okay, you're also allowed to just put the P on the left and put that on the right. And as we did in the first example, mathematicians say that A over B is the same as A times 1 over B. Okay, so we're going to apply that here so that we have 105 times 105 times 1 over that whole thing there, which is what we have there. Okay, and another thing we're going to apply is this law of exponents that says 1 over a to the power 2 the same as a to the power minus 2, right? So we're going to apply that, take this as our A, take this as our A, take this as our A, and then we go 1 plus 0.05 to the power minus 2. Are we all together? So therefore, it means that I'm able to substitute this with that. It's the same thing, literally the same thing. So I have that line over there. Yes, ma'am. Yes. Okay. Okay. So Ufenza says that I'm crackling. Is that the right word? Yes. Gyakata. Is it the same to the rest of you, or is it probably just her? Please speak so that I know what's going on and I can solve the problem. Okay. So I'm gonna wait for Ufenza. Ufenza, log out and back in. I'm gonna wait for you, ne? Ufenza Nzwane. I've got two fences. Yes. Double-edged, sort of got a double-edged sword. I've got two fences. I'm gonna wait for Fencer to come back, and then while we wait for Fencer, Tsoku's got a question. Yeah, cool. Tsoku, we've got a question, right? You've got a question, right? Yeah, you good? Yes, boss. Okay. Tsoku says I'm also lagging on this side. Am I also lagging at Tato's side, Lamla's side, Siro's side, Babala's side, Offense, Ndebele's side, Lebu, Chauke, Tumelo, Lοχoro, Nozipho Zona? Am I also lagging on your side? Am I cutting? Or my do you hear my thingy late? Sometimes. Okay. Okay, so that yes, but someone said here, but say talk, bro. Yes. Oh, yes. Nah, I hear you, my king. I hear you, my king. It's Ukwarich. I hear you. Okay. This guy, Timelo sounds. You sound like a brew dog. You sound like yo brew, chance, yo brew. Sound a bit like brew. Hey, nigga, what's going on? You bleaching, brew? Bleaching, hey? Joking, bro. Okay, I know Rirabot. Sharp. Offense back. Offense Ntswan. Yes, she is. Okay, she's back. Offense wango yal o sharp yal. Ke a kwagala gabotse. All right. Modimo ko mogolo ba kgale, I'm leboga. Okay, Fere, where was I? Was here. So remember, what are we calculating? We're calculating the loan amount. We are given that he's gonna pay 105 in 2 months' time. So I literally did everything until I got to this point, and then like I punched this into my calculator, got the initial value 9.95.23809.524, which is the value in the first scenario that we found. Like, remember, I started the scenario by saying that he bought it this much, and then I sort of cancelled it, and then asked you guys to find that, and then yeah, the reverse of it. Okay, you guys get the point. I'm feeling too articulated, but you guys get the point. So yeah, so that's essentially that. That's how much. He's gonna borrow initially, such that after 2 months he pays them back 105. Okay, so I also did another summary similar to the previous summary. So your loan amount is basically the future payment discounted back to the present day. So I took the 105, instead of me putting it into the future, I I took it back to the present by 2 periods. So then I get that value 9.5 what not. Okay, 95 point what. Okay, so now what's gonna happen now is I'm gonna put the two accounts together. Okay, and I'm gonna put the two accounts together. And in what sense? I'm gonna put the two calculations of the loan amounts together. The calculation for the loan amount for scenario 2 for account 2 is this, and then for the account 1 was 1 there. Okay, so this account 1, the loan amount, it's 105. Where's that thing? Yes, it's 105 brought back to the present day. Remember that you would pay 105 after a month on account 1. Then I take it back a period, it gives me 100. Fair? Then on account 2, he would pay 105. I take it back 2 periods, 1 2. Hence the minus 2 there. Are we all happy? Please do not forget this. The loan amount, don't forget this line. I was taught this by my own lecturer. I won't mention her name. Azani. Okay, that's her name. She said, the loan amount, or like the loan amount of or under any account, is essentially the future payments or future installments towards that loan brought back to the present day or discounted back to the present day. So that's exactly what's going on account 1 and account 2. It's the future payment, I bring it back to the present day. Future payment, I bring it back to the present day. That's essentially that. Easy peasy. Okay, so that's what I have there. Put everything on the same timeline, easy to see. Then I just put, okay, total loan amount, it's at 100 plus 9.5, which gives us 195.23 whatnot. Okay, fair. Now, I want to derive a shortcut formula to this. You see, it took us like 36 minutes to get to this point for me to explain this. So now I'm going to derive a shortcut formula. As you know, we always have like shortcuts in maths. Okay, so I'm going to take this young calculation, the value there, the 100 and the 95 point whatnot. I'll just call it 95 from now. 195. Okay, I'm going to split them. Okay, so I'm going to take this 100 instead of me writing the 100. Okay, let's put it this way. This is the total loan amount, 195 fair. So I'm gonna split it. It's the 195 fair sharp. Then I'm gonna put this 100 in this form. So I'm putting this 100 in this form, in its discounted form or discount form, however you can call it. Ne? So this is 100, and then this discount form as well. This is 95. I get? Are we all happy with the substitution? Yes. Yes. Okay, fair. Now I put that together. Ne? Then I'm going to introduce a third account. I apologize if this is too much. I'm going to introduce a third account. There's nothing complicated here. In this third account at the beginning, same beginning. Ne? Same beginning here. Same beginning. He what's this thing? He loans out 90.7 from the bank and promises to pay in 3 months' time, in the third month. How much does he promise to pay? Basically that 105. Okay, so now if you were like asked to if you're not given this 90 point whatnot, and you're given this guy's gonna pay 105 in 3 months' time, how much is the loan amount? You use this formula. You literally write the amount he's going to pay the installment, discount it back to the present day. So remember, it's after the third month, so you must discount it 3 periods back. Then this gives us 90.7, which is what we had at the beginning of the example. This just to show you what are we all happy with that? So it's now 3 accounts. We put all of them together. Are we all happy? Loan 1, loan 2, loan 3. Please speak. I want to hear your voice. Okay, you good? Lebo Chauke, is jy reg? Mashapa, is jy reg my broer? Verstaan jy? Lekker broer, yeah. So that's about that. So if he, from his point of view, when he calculates the total loan amount, he's just going to add all of these three: 100 plus 95 plus 90, and that's his total loan amount. Doesn't care whether it's account 1 or account 2, it doesn't matter. Yeah, so he's just going to add all of them up, and when he does that, the 100, the 95, and 90, that's a total of 285 points. So that means at the beginning of January, he borrowed a total of 285 friends. That's it. Ne? So that's about the 285. I'm gonna put these values into their discount format. So the first 100, the 100 rather, I'm gonna put it in the form 105, 1 plus 0.01, discounted back to the present day for one period. This one, 2 periods, 3 periods. It's literally the same thing. That's fine. And then on top of that, after doing that, I'm gonna split this thing. You guys remember what? A to the power 2 is equal to a to the power 1, a to the power 1, right? Do you guys agree with me? A to the power minus 2 is also the same as a to the power minus 1, a to the power minus 1, because when the bases are the same, we have the exponents, and this will give us minus 2. So I'm gonna apply this there. Ne? I'm gonna apply this there such that I have my 1 plus 0.05 to the power minus 1, 0.05 to the power minus 1 there. Do you guys see that? How I split this? The 105 remains. Fair. I do the same there. I split it 3 times. 1, 2, 3. The 105 still remains there. No worries there. Now, the textbook, the Rahob Education textbook says this looks like a geometric series. It is in fact a geometric series. Why does the book claim that it is a geometric series? Because when you calculate the ratio, T1 and T2, take this as a T1, sorry, T1 and this is T2, and go T2 divided by T1. Here's my T2, this, divide by T1, here's my T1. And then obviously I've got the same base. I've got like something like this. Let me write it nicely. Yes, I wrote it already. So a to the power m over n is same as a to the power m minus n. That's literally that. So this is my a. So I can just simply subtract the exponents. So here's my m. My m is minus 2. And then this minus. And then after that, minus 1. Okay, this gives us an answer of minus 1. This is my ratio. So it's 1 plus 0.05 to the power minus 1. Okay, that's my ratio. So obviously, I can't just test it here. I also need to try T3 over T2. If it matches, then I know that's indeed my ratio. If you do that, you actually find that you get the same answer. I didn't do it here, but yeah, you get the same answer. So now, you guys can agree with me, or yeah, so you guys can agree with me. This number is less than 1. It is 1 over 1 plus 0.05, which is 1 over 1 plus 1 over 1 over 1.05. If you calculate, it's less than minus 1. You guys remember when we're dealing with a geometric series and you've got your ratio less than minus 1, you conventionally use this, even though both would work, but conventionally you use this one. Sn equals a to the power 1 minus r to the power n over 1 minus r. Are we together? You guys know that video. That video. It's like it's a this British kid who's complaining about Father Christmas. Like he's like what? He's like I'm not. It's like I'm not on the naughty list. I'm on the good list. You guys know that video? You guys know that video? But Father Christmas stop being very nice to me. That kid kills me, bro. So yeah, you guys get the story. So yeah, that's the formula we use normally when like a ratio is less than minus 1. Even though both of them will work, but it's always user friendly to follow that sort of like convention. Fair? So you guys remember that A is our first term. In our case, our first term is this. The 100. Yes, I know it's 100, but we put it in discounted form. So that's our T1. And our ratio, we just found it there. This is our ratio as well. Then our n is the number of terms. You guys remember that on this calculation, n represents the number of terms that you're calculating. So our n in this case should also be number of terms, which is how many? 1, 2, 3. So we've got 3 thingies, number of terms. Okay. So now I'm going to go ahead and substitute into this exactly all of those values. So my a is that substituted there. Then 1 minus r. R is the constant ratio, which is that substituted there to the power minus 1. And then my my n is the number of terms just established as 3. Now I'm going to simplify all of this thing to make it easy to analyze. Okay, I'm going to simplify this thing. Very easy to simplify. Okay, are we all happy with the substitution before we move forward? I'm going to pause for 30 seconds so that you guys can connect the substitutions. I'm going to pause for 45 seconds actually for you guys to see the substitution. Okay, please look at the substitution. Substitute like mentally. Don't write it down. Mentally and then be happy. 45 seconds. Yes, ma'am. Thank you, ma'am. Thank you, ma'am. I corrected in the book. Yes, thank you so much, ma'am. Who's that? Who's that? Ah, beautiful. It's absolutely beautiful, mate. I'm saying this in Jackson's voice. It's Absolutely beautiful. Okay, yeah. Thank you for that, my sister. So my sister is saying that like my R, okay, we found that our R is this, ne? But I substituted it wrongly there. So instead of me putting like what's this thing? Instead of me saying R is on my statement there, instead of me saying R is actually that, but I put 105 there because I was copying and pasting, so made that mistake. But in the substitution, everything is proper. So yeah. Are we all happy? Can we proceed? No, no, no. Of course, Father Christmas not being very nice to me. But nah, dog, you're not gonna get gifts for Christmas. Like, I'm gonna punch his beard off. Punch him. I like, this kid's gonna give his parents problems when he grows up. Yes, yes. Okay, that's a substitute. So I'm gonna simplify this. Yeah. So I'm gonna start by basically multiplying these two. You guys remember what mathematicians say that when you have a to the power m, a number to the power of something, to the power of something, you just multiply the two exponents. So I'm gonna multiply the 1 minus 1 by the 3. So that's what I did there. Okay, obviously I'm gonna get minus 3. Proper stuff. Okay, now here I'm gonna apply this law of exponents for this part. A to the power minus 1 is equal to a to the power is a to the power minus 1 equal to 1 over a to the power 1, right? Or generally speaking, a to the power minus n is equal to 1 over a to the power n. You just make 1 over and then remove the negative and put a positive. Okay, so that's what I applied there and I got that. Okay, I could even remove the 1 because I don't have to keep it. Okay, I removed it there, as you can see. Then after, I worked on this. You guys remember lots of exponents, or fractions say that, ne? If you have something like this, you could go ahead and find the lowest common multiple, whatnot. But the quickest way to solve something like this, ne, is you multiply the numerators together, put the sign in the middle, then cross multiply and have AD, cross multiply and have CB. You guys remember that? Yes or no? Big man thing. Sharp. So we happy? Yes. So now I'm gonna apply that. This is the same as over 1. So I'm gonna multiply these two thingies, denominators. So when I multiply 1 by this, I get that. And then after that, I cross multiply this with that, this with that. So I get 1 plus 0.05. With 1 times 0.05 gives me that 1 plus 0.05. And then I go 1 cross multiply. 1 times 1 gives me 1. So that's why I have a 1 there. Are we all happy? The sign still remains negative. Are we all happy with what I did there? Proper stuff. Then from here, what I do is I sort of work this thing out. So it's just 1 plus 0.05, 1 plus 0.05 minus 1. This one will sort of minus that one over there. Will be left with 0.05. 0.05, yes, that's fine. Okay, fitted. This is where we add now. Then the next step I want to take is this. Ne? You guys know what A over B is literally the same as A divided by B. For example, 6 divided by 2 is literally the same as 6 over 2 same as 6 divided by 2. The division sign and the over sign is one and the same thing. If I say, if the president is passing, I say Cyril is going to look. If I say cupcake is going to look, let's say Matam is going to look. It's literally the same thing, right? You sleeping is the same as you being awake. So the division sign is the same as over sign. So what I'm going to do from here is that I'm going to change this thing to like the division sign such that I get this whole thing here divide by that thing over there. Do you guys see? Lord have mercy. Proper stuff. Then you guys remember what mathematicians kamuka, including yourself, you're also a mathematician in the making. A over B divided by C over D. Ne? Come on. Why's the pet not biting? Okay, if you have something like this, mathematicians say that you're allowed to rewrite the first fraction, change this division sign to a times, and swap the denominator with the numerator on what follows after. Don't tamper with this. D over C. Similarly, we're going to change this thing to a times and then swap these two. This comes there, this comes there. So we're going to have 1 plus 0.05 over 0.05. Fere. And then after that, you guys remember from this, you're allowed to multiply this and this, this and that. That's allowed. So I'm gonna do exactly that. I'm gonna multiply this numerator with this numerator. Remember that this same is over 1. So I'm gonna multiply this numerator with that numerator. Okay. Um, there I have it. I multiplied, and I multiply this denominator with this denominator of 1. Then I got 0.05. And then after that, I could just sort of group these two. Remember that A times B times C is literally, or gives you the same answer as in A times C times B. When you multiply, the order doesn't matter. This is what we call the commutative property of multiplication. The order doesn't matter. All right? 2 times 3 times 4 is equal to 24. Even if you do this 2 times 4 times 3, it'll still give you 24. Right? So I'm going to apply that on the numerator. So I'm going to sort of group this and that. Ne? So I've got a to the power minus 1. It's a thing to the power minus 1. Ne? Times a to the power 1. This is same as power 1. So this will give me a to the power minus 1 plus 1. When the base are the same as the exponents, which gives you a to the power 0, which is just 1. So therefore, this and this was essentially cancel in that way. So then when those two cancel, I'm putting them next to each other. That's fine. When they cancel, you're left with nothing there. Okay, and then whatever remains there remains, and then the denominator is there. Are we all happy with how these two cancel? That's what I literally did there. Yes, good people. Yes. Proper stuff. Mashapa, ushapa bafana. Kungao, right mtase. Yeah, the phrase I remember now. I don't know if I don't know if I said the 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 phrase correct the other time. The guy said, Utiko ondimthandazayo. Utiko wakuva masinyane. Yeah, I said that. Can Lamla can you say it for me like nicely? Utiko ondimthandazayo. Utiko okuva masinyane. Can you say it Lamla for me there, Pozayam? Lomchita uti. Utiko ondimthandazayo. Utiko okuva masinyane. But say it fast. Say it the whole thing fast. Utiko. Yes. Hey, Jesus. That's what I was looking for. The accent and everything. Ah, man. I was watching this comedy, I was laughing. But when I heard that thing, I was like, aye, man. Aye, this is too much. Too much. Okay, fair. Lamla. Come on, Jama Wutzi. Okay, fair. So, yeah. So, this is the story. So, these two cancelled there. And then we left with a 1. 1 times 105 is nothing. So, you have that situation. So, then the textbook asks you, what do you notice there? You notice, Ore, this 105 is what he paid at the end of the first month under account 1. He also paid 105 at the end of the second month under account 2. He also paid 105 at the end of the third month under account 3. What other thing you notice is this 0.05 is obviously the 5% with which the money grows, or the investment environment that which with that the investment environment is giving you, or with which the money grows from the bank point of view. And then this 3 is the number of terms. You guys remember that we had the 3 sort of payments, and then obviously this what we have in our denominator is our I. It's a percentage as well. So therefore, that's exactly what I explained there. And then when you punch this, you get the same answers. And when we sort of edit them manually, when we edit them manually, we got that same answer. So now when you use the shortcut as well, you get the same answer. When you look at it closely, you realize that where's that thing? Why is it not scrolling? Please don't scroll too much because I need to show my students this fantastic, nice thing. Stop. Okay. So you realize that this is your X, this is your Y, and this is your N, and this is your Y as well. And therefore, this simplifies to P equals X, 1 minus 1 plus the I, the N, and the I there. Nothing is more delicious than this. Oh, Lord have mercy. Compare this with that, or that. with that. My 105, the monthly payment, X. My I, 0.05 there. My number of terms, N. And then my I there as well at the bottom there. I'm going to pause for 1 minute for you guys to digest, understand, overstand, and understand. 1 minute and 5 questions, my God, people. No, nike ixesha nelifanele. So you guys understand, eh? Are we all happy? Bogoro, chokwe, jonono. Okay, fair bafowethu. So this is the present value formula, all right? I want you guys to be super ultra careful here, ne? Listen to what this thing says here, ne? Did I explain that? I think I did. Did I? Didn't I? Yes, I did. So pay attention. This happens to be the general formula for calculating original loan amounts or an original loan amount, in which X is the regular payment. So forget about account 1, 2, and 3. Think of it as just one bank. Then he takes out a loan of 285 at the beginning, and he promises to pay 105 at the end of every month. So think of it that way. Ne? So X is the regular payment, I is the interest over some period, monthly, quarterly, whatever it is. Ne? Remember, when you're working quarterly, you have to divide the maybe 60% by 4. Right now, you guys get the story. The same way here, they said the interest environment is 60% per annum compounded monthly. So what we did was, first of all, took the 60%, and we know that 60% is the same as 60 over 100. I told you that percentage means over 100. This is 0.6, okay? Then you're going to take this 0.6, you're going to split it 12 times, because there's no way that if everything happens over a month, you can't say this thing gains interest over 60% interest over. No, you have to split the 60% into 12 pieces, because each month takes its own piece. So therefore goes 0.6 divided by 12. So that's how you should have sort of look at it. So that's the interest we're talking about here. Interest over some period, monthly, quarterly, whatever. And the N, this is the most delicate, dangerous, gevaarlijk, ingozi part. This N does not, you guys remember the feature value, those of you who bothered to attend last week, you got baptized with this thing last week. Okay, you guys remember I specifically said that this means, those who attended, this means the number of payments. Number of payments. All right. Then this here does not mean the number of years, means the number of payments. So if you're in a year and you make installments out if you're working over a period of a year, paying back a loan over a period of a year, and then like you make the payment at the end of every month. So the end is not going to be 1 because it's 1 year. It's going to be 12 because you're paying the stuff 12 times, every at the end of every month. If you pay the like make the monthly the payment, sorry, the regular payment quarterly, we've got 4 quarters in a year, so therefore this will be 4. That's the number of payments when we're dealing with future value. For present value, this means N is the time remaining to repay the loan. Another way to look at it is the number of periods until the last payment on the loan. I repeat, it is the number of payments are left. The number, no. The number, yes, no, sorry about that. It is indeed is the time remaining to repay the loan, which basically means that it is we're time one, time one, time two, time three. You guys remember that we had 105 here, 105, 105. So when you're doing your calculation there initially, ne, and they ask you to find the loan amount, they tell you this guy pays 105, 105, 105. Your calculation would be substitute your 105 there, your x, 1 minus 1 plus the 0.05 minus the n will be the number of the time remaining to repay the loan. So the last payment is here, is at time 3. So how many periods do we have? 1, 2, 3. So this will be a 3. Okay. So if this guy was paying making payments until the last payment, which is at the end of December, for example. Just give an example, 31st of December, that's the last payment. This would then be 12 because this means the time remaining to repay the loan. This is the last payment. This helps us. This approach helps us in this sort of calculations. When someone is paying a loan and then they tell you at time 4, immediately after making his fourth payment, what is the balance on the loan? So that means this guy like, okay, at time 4, I decide to pay back the loan. How much do I need to pay back the bank? He goes to the bank and asks that question. This is how you're gonna calculate it. You're gonna do the same thing. 105, 1 plus 1 plus 0, 0.05, whatever. And then here you're gonna put the time remaining until the time remaining to repay the loan. So you're gonna count the periods until 12. 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. So you're gonna put 8 there. So this will be the balance then. That is immediately after making the payment at time 4. What is the balance remain? If you decided that I'm gonna pay back the bank and I don't want anything to do with them, that's how much you would pay. Does that make sense? That explanation? Does it make sense? Please confirm, Afrit. This is delicious for me. And the funny thing, I discovered this at varsity. I was pissed at. Okay, let me shut up. Yeah, are we all happy? In first year. Are you guys happy? A couple you guys are not reacting. So, ku no zipho, sharpisto, kunga ozona. Okay, proper stuff. So yeah, very, very important. Proper stuff. N under the future value calculation means the number of payments. And then the N under the present value situation means the time remaining to repay the loan. Another way to look at it is to say the number of periods until the last payment. So remember at time 4 here, I said 1, 2, the number of periods. So if you're working in months, this is how you count. If you're making the payments quarterly, you must just count the quarters. Don't count the months, count the quarters. So you're working according to what they give you. Okay, fair. So here I was just showing you the calculation. I redid everything. So put all of the 3 accounts together. This guy pays 105 at the end of every month for 3 months. So this is the calculation. I put the 105 there, 0. Whatever. Put 3 there, get the same answer. If you like, you can just discount each one of them. So the first 105, you discount it back to the present day. We have that. The second 105, he makes count it to the present day. That's 2 periods. Okay, there we have it. And then the last one discounted 3 periods back. We have that. We get the same answer. So you guys now officially understand why we use this. The logic behind you can either use this or that. But obviously, since we're working under pressure, exam pressure, time, and all of that stuff, we're gonna use this formula. Ne? But you now understand what's going on. Okay? Are you alright? Yes. Yeah. Sharp. Let's just say this is actually what the book asks after. Let's see at this time. Let's fade yield. Okay. Now let's now analyze typology situation more in order to understand the concept. Please pay attention. Assume that we're at time 1. Oh yes. Yeah. So we are now going to analyze this deeper. I just want to show you something. This will help you or help give you like a proper understanding on how to calculate balance on a loan. Okay, it says assume that. So we're still looking at the same scenario. Ne? So my guy here takes out a loan of 285.94. He pays back 105 time 1, time 2, time 3. Yes, ma'am. Oh, yes, you're right. Thank you, ma'am. Okay. So I presume now you can see it, ne? All right, proper stuff. So I'm saying that we're going to analyze we're going to use this same scenario to analyze this concept a bit deeper. So remember, in summary, the guy had three accounts, so they just made it into one, and then like he borrowed a lump sum or like a large amount of 285 at the beginning of the year, and then he repays back the loan in the form of 105 payments at the end of every month until the last month. Okay, then the question comes in the exam and says, what was the loan amount? We know how to calculate it. We literally apply this formula, the loan amount, we apply this formula. In place of X, we put the 105. The I, we already know. The N, the number of payments, the number of periods until the last payment. Okay. So we are here, we want to know the loan amount. So number of periods until the last payment, 1, 2, 3. We're working in months. If we're working in quarters, your calculation will just be your discount value, your value here would -1 because you're working with 3 months, which is just 1 quarter. So it just depends on what you're dealing with. So we got that, we understand. So now we want to analyze this deeper, like I said. So let's just say, okay, this is time now, and then this is time one. This is at the end of the first month, ne? And then now the 31st of January. Okay, let's just assume it's today, and then he literally makes this payment. You guys remember that? How does he make the payments? It's not like he goes to the bank and gives them the 105. No, he sets up a debit order. So the bank will automatically like take out the 105s. Okay, that's how it happens. So now let's just assume we're at time one, and then at this moment the bank debits 105. It deducts 105 from his account, which is just the payment. Immediately after debiting that account, what is the balance on the loan? Put in a different way, what amount does he have to pay in order for him to like close the whole thing, so that it doesn't have to make this payment and that payment there? What is the balance on the loan to close the account? This is how you calculate it. You literally use the same formula, the present value formula. Okay, you go x 1 minus, you guys know, you must know this thing by heart. Akunyaka mathata na. Anyaka motho o tsaka exam a phuthulla. O phuthulang ko sento wa e tseba. E creme sa le go mvala. Please. Okay? Skapais. So sharp, use the same formula, ne? So now remember I said we at time one, the bank just debited the 105. Now this guy is like, man, I wanna pay back all of this, man, and just get it over and done with. I don't wanna pay back this loan. So how much does he need to pay back to the bank after making the 105 payment? This is how you calculate it. You're gonna say, so you're looking for the balance, outstanding balance or balance of the loan. You do this. Use the same formula. Put the 105, put 105 there. 1 minus your interest. What do you put there? I told you that this means the number of periods until the last payment. 1, 2, you're going to put -2 there. That's the number of periods until the last payment. Over 0.05. And then the value you get will be the balance outstanding. So I literally did that there and got this amount. You calculate, punch this, guys. Can you guys punch this in for me and confirm if you get the same amount? Let me just rewrite it because it's ugly. You use the same formula. You apply the logic that I gave you. Hey, my pen. Why are you doing this to me? Oh, mate, what are you doing to me? Okay, my pen just stopped working. Let's just quickly take out the battery and put it back in and see if it works. Come on, pen, don't do this to me. Are we... Okay, guys, just a second. But while you guys wait for me, do the calculation because you guys know what's going on. So please. Don't be lazy. You know what King Solomon said about lazy people? He says a little sleep here and there, hunger or poverty will come to you like a bandit, like a thief. So that's what King Solomon said. So he was the smartest guy in history. So who am I to dispute that? Okay, Fere, your pen isn't working. Is it the screen or the pen? Oh yeah, it's the thingy. The what's this thing? It's the document. It just froze. So what I'm gonna do is I'm gonna close it. I'm gonna close the document, yeah, and reopen it. Okay, it's closing now. Just bear with me. It's closing. Okay, it's closed now, yeah. So I'm gonna open it. I hope Ish. Takes me back to the first page. Table of contents. What page is this again? Financial maths. Oh god. This is even grade 12. Okay, yeah. That's 97 there. Offense is the book, right? 197. Yes. Where was I, mate? I was yeah. Okay, I'm here, yeah. Do you guys see the thingy? Okay, let me reshare it, sorry. Let's reshare it. Because it's gone now. Okay, Fede. So yeah, I was here. Then I asked you guys to do a calculation. Did you guys get the value of 195.2324? Yes or no? Okay. So my question is, do you guys remember that I said what happens when, let's just say after time one, we're time one, let's just say we're time one after a month, and then this guy pays the 105 or the bank debits 105, takes out 105 from his account. So, and he decides, I man, I want to I want to close this account, man. I want to pay back these people their money and just close this account. How much do I need to pay? So that's how you calculate it. You still use so you're basically looking for the balance on the loan or outstanding balance. You literally use the present value formula, x present value, PV or P doesn't matter. 1 minus 1 plus I to the power minus n, close bracket all over I. Okay, your thingy, your x is the 105. Okay, 1 minus the I, you guys know how to calculate it already. I've overemphasized that. Minus the 3, ultra important, means the number of periods until the last payment. So since we're working in months, we've got 1, 2 periods. So you're going to put minus 2 there. If we're working in in quarters, ne, if you're working in quarters and this is the last payment, let's just say time 4, then this will just be 1 because a quarter is just 3 months. You guys see that? Yes? Very, very delicate. Very important. You mustn't make a mistake there. So over I is 0.05, which gives you an answer of 195.23. So that's what it is. Okay. Think of it this way. Think of it this another way to look at it. Tapela's friend by the name of Jack takes out a loan of 195 at time 1. So after Tapela makes this payment, I'm just giving you another like point of view. A friend of his, Jack, takes out a loan for 195.23 whatnot. Ne? And then he's going to take this loan and then it's going to run for 2 months. So that means here this guy will pay 105, also pay 105. So if you do the like present value calculation, you actually realize that it's literally the same thing. Yeah, well, so yeah. And then the question says, let's see, the loan amount Jack took out from the bank is charged at 60% compounded monthly. If we had not been given the loan amount Jack got, how much? How would you calculate it using the future payments? So let's just say we're not given this amount, ne? And they tell us that Jack takes out a loan at time 1, ne? Takes out a loan at time 1, and then he's gonna pay back the bank in the form of this payment and that payment. So how would you calculate the loan amount? As I said, the loan amount of a man is basically the loan amount. Um, what's the thing? The loan amount is calculated by taking all of the future payments, discounting each one back to the present day. So you're gonna take this 105, discount it back to the present day, 1 month minus 1. This one, 2 months, 1, 2. That's how you do the calculation to get this answer. Let's see if that is the case. Let's do that. So we do that there, literally that. So the 105 discounted back to the present day, 1 period, 105, 2 periods. As you can see, we discount the 105 back 1 period to the current time. We discount the 105 back to 2 periods to the current time. So this gives us that 105 current time, current time. This gives us 195.23, which is literally the loan amount that we got at the beginning. Easy peasy, ne? If when you guys open for your maths, ne? Okay, it's gonna sound arrogant. Let's leave it. Okay, are you guys happy? Another way to calculate this, you could use that discount sort of thingy, or you could use the present value and go the 105. That's you doing the same calculation, yeah? The 105, then 1 minus 1 plus 0.05 minus, remember I said that an outstanding amount is basically, sorry, the n represents the number of periods until the last payment, 1, 2. So you're going to put 2 there because we're working in months. And then when you put your 0.05, then can you guys calculate it for me? Do this calculation for me there and see if you get the same answer of 195 point whatnot. Can you guys do it on your side as well? I'm also doing it on my side. As you can see, I'm punching the calculator. You guys can hear me. I'm punching on my side. I'm still trying to see if I'll get the same answer because I'm also learning. Tuto ga e fele bagala. Tuto ga e fele. Yeah, what do you get? Please, please, please. Thetha mntanami. Bolela, bolela ngwanaka. Bolela. I'm waiting. Zona, bolela, babalelo, bolela, legoro, bolela. Chabang khan. Can you guys speak into the mic and tell me what answer you get there? Interesting. And Babalel, what did you get? Babal. All right. Okay. Proper stuff. When you're done, just let me know what you get. Lohoro is very quiet. Lohoro, you are suspiciously quiet. Suspiciously. Kana, who's lit? What's Letabo? Is Letabo here? Is Letabo here? No. Okay. Oh, Kana Tabo is in grade 11. Oh, yes, grade 11. Okay. Feed. I'm just waiting for Babalele to confirm the answer. Chirofato, you've been suspiciously quiet as well. Proper stuff. Tsego, you've been quiet. Speak to me, Tsego. So Chiro, Belelena, that's it. Gabotse. Modimo ko mogolo wa kgaladi. Modimo ko mogolo, so you get the same as you see. So you guys can use the formula or this whole discounting thing. So once you guys master it, I guess I'm gonna share with you the recording. So you could also like revert back to the whole class and then just rewatch it. So once you guys once you guys master this whole future value thing using the formula, sorry, present value using the formula, and this whole discount thing, you're done. I mastered it in first year. As a second year at varsity, yo, I was bitterly disappointed that why didn't my teachers teach me this? Oh, fair, maar go tlo loka, Modimo ko mogolo. I'll never get rest until one of my learners get 100% in maths. You guys understand what's going on now, yeah? So we're gonna do a bunch of questions. Yeah. So I also like emphasized again that to calculate the amount of standing, you still use the same formula and what. And at the end, it's the time remaining to finish repaying the loan. And I said, don't you dare forget this in the textbook. So yes, it doesn't sound like polite, but anything to force you to pass. All right, so you guys are gonna do me this question, yeah? You guys will do me this question, this example here. Yes, I'm giving you guys 5 minutes. Please do this for me. The time now is 19 past. You should be done by 24 past. Let's go. Feel free to ask questions. And you do not have to submit it, ne? Don't have to submit it. Just do it and get it right. 5 minutes, my good people. Please don't forget that. Yes, boss. Yes, boss. Didn't get it, boss. Can you repeat yourself? Oh, share screen. Oh, okay, sorry, boss. Okay, unshare. I just unshared the screen and I've just reshared. And guys, please note that the personality that I give during the session is not my true personality. Ne? It's like acting. It's my professional personality. Ne? Once you bump into me in person, I'm totally different. I'm more quiet and shy and calm. You won't even notice me. I'm just easy. I don't talk too much. Ne? This is just my stage personality. 5 minutes of it, ne? Please. Uh, 1 minute left. Please, when you're done, just raise up your digital hand, and I can see. You guys know the song? Ba ba nyo really, hey ba nyo really, klong li itlek metsi. You guys know the si di wing sabu bilo sa fele. Who knows that song? Who knows that song? Come on, come on. Ah, fakana ba't na correct one? Iring ka English. Iring ka lyrics. Oh, iring, bolela lyric. Or like, just give me the lyrics. Please, please, ke a kgopela bana. Yeah, yeah, but what's the name of the song in English? I wanna, like, yeah, listen to it in English. I'm sure it slaps. If it slaps in Sepedi, surely it should slap in English. Yeah, please, ish, yeah, please, please. Ish, our song's nice. Yeah, it says, va, ere, he, va, nyo, rile, klong, li, hitleng, metsing, si, diveng, savu, pilo, wasa, fele. Ah, that song clobbers me. Okay, are we all done? What's going on? Yes, Pelo? Is it klaar, my bro? Um, Debele offense. Are you done? Qedile. uNkulunkulu mkhulu. So ngathatha usoshaphula wena tata or ufedile chokot. Nozipho you're quiet. Ufedile. Qedile mntase. All right, Kofi, how many more minutes you want or seconds or what? Okay, I presume her silence means that I need just 1 minute. Okay, I'm gonna pause. I'm gonna wait for you just 1 minute, and then like yeah, we work together. Just want to make sure that now you have a feel of what you're doing, you see what you did, and then you also compare it with what we do as a class. Okay, Zoku, you've got a question, mate? Oh, Zoku's done. It's good. All right. Level Chago, did you find the lyrics for me? What? Singing. Yeah, sewing is like SEW. Yes. Okay. Okay, thank you so much. I'm gonna listen to it after the session. Oh, Mdimo ko maholo wa kala. Okay, thank you so much. I appreciate it. Okay, let's stop writing and just yeah work together. Let's see if we're gonna get this right as a class. So Mary takes out. Why do I always put biblical names? Mary takes out a loan from the bank today. Okay, fair. The bank charges interest at 60% per annum compounded monthly. We all understand what that means. She will repay the loan with monthly installments of 105. She will take the loan. She will make the payments for 1 year. So, okay, Umeri goes to the bank today. Assume that today is the 1st of January, whatever it is, 2025. And then she takes out a loan. And then she's going to repay the loan in the form of monthly installments of 105. All right. Then she's going to make these loan repayments for a year. So essentially, she's going to make 12 payments of 105 because she's making the payments over the year. Okay. Fair. Calculate the loan amount Mary is given today. Okay. There's two ways in which you can calculate this. You could use the present value formula or that discount method. Let's start with the present value formula because that's easy. So it says there are obviously two, that's not two methods to this. The formula, which is that, and using discounting. I'll show both of them. That's what the book says. Okay. So in place of the X, we put the 105. In place of the I, we put the interest. And how do you calculate the interest? This is per annum. So you go 60% divided by 60%, which is just 60 divided by 100, which is 0.6. And then after that, you split the 6% into 12 because it compounds monthly. If it was quarterly, then divide it by 4. Okay, this gives us 0.05. That's what we have there. And then now this n. N is the, remember I said what n means in terms of present value? It means the number of periods until the last payment. Okay. So now, so we are at the beginning. Did I draw a timeline? Yes. We're at the beginning here. Ne? This is the 1st of January, right? They like, this person's going to make monthly payments of 105. Okay. Until the 31st of December. That makes it 12. So now I said the n means the number of periods until the last payment, which is you here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that means um, the number of periods until the last payment is 12. So in place of the n there, you put a 12. Okay, so we substitute everything, we get the 12, we get an answer of 930.64. Who got this right? So rotela matsogo, rotela matsogo. Well done, well done. Well done, well done, well done, well done, well done. Proud of you. So if we were on the whiteboard, I'll give you a star, but we're not on the whiteboard. Okay. But I'll stick a star on your forehead. Ne? Feda, this is the formula method. This is the quickest method. This is the method you're going to use in the exam. Unless you're cornered and you feel like using the discount method would be more sensible. Okay, let's use the discount method. So these are the times at which she makes the 105 payments. Okay, so I put them there on each period. Okay, then I'm going to discount each one of them. Look, discount this one, the first 105, I discount it back to the present day once. This one, 2 periods, 3 periods, 4 periods, and so on. So I've got all of them there until the one that discounts 12 periods. This will still give you an answer of 930.64. Therefore, Mary borrowed from the bank 930.64 from the bank. Okay, that's about that, easy peasy. Then the second question asked us to ask us how much does Mary owe the bank immediately after her ninth installment. Okay, this is very delicious. How much does Mary owe the bank immediately after her ninth installment? Okay, so we're gonna go to time 9. Ne? Here's time 9. Ne? So now you guys remember that how does Mary like make these installments through probably a debit order? So the bank would just like debit 105 from her account at the end of every month. Okay, so we know you know what that is, debit order. So now the question is asking you what like how much does the customer still owe the bank immediately after the bank debits 105? Okay, that's the story. So they debit 105 today. Let's just say it's today, time 9. Then what is the balance outstanding? Meaning that if she decides to just settle the balance today, how much does she need to pay? Okay, so this is how you calculate it. You're going to use the same present value formula. Ne? P equals X 1 minus 1 plus 1 plus I to the power n equal to, substitute 105, 1 minus 1 plus the 0.05 minus this is the number of periods until the last payment. 1, 2, 3. You put 3 there. You see, easy peasy, and then get your answer. Okay, so you can either use this formula or the discount method. Okay, so this will give you an answer of how much. Let's see. B was B. Okay, here's B. So let's use the formula. Here's the formula. We used it. We got a mark an answer of 285.94. Let us use the discount method. You guys see this, ne? That's what I just wrote at the top. And if we use like the discount method, so we are time 9. So I said that a loan amount is basically the future, all of the future payments discounted back to the present day. So immediately after making this payment, what does it owe the bank? So you're going to take this future payment discounted once, take this future payment discounted twice, this future payment discounted 3 times, and just add the values. So that's exactly what I did. Discounted once, twice, 3 times. This still gives you the exact same value. Agar. Yes, 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 yes. I'm gonna stop the session here. I'm gonna continue again during the week. I'm gonna announce when we'll have our second class, but it's gonna be like in the morning, like yeah, maybe around 10 or something. But it's not gonna be tomorrow though. It's gonna be like maybe the day after tomorrow. But I'm gonna make an official announcement tomorrow as to when we would have the class. Okay. So yeah, those of you who want the Rahov Education textbook, please order. And you see that that's super easy. Today, I did not prepare for the session. I wanted to teach you guys on the whiteboard so that I could write. But I came back home late from something. And then it was half past. I came back at 6:30. Then I was like, now I can't move the session. I need to give my students a class and it has to be proper in terms of future value. Then I opened the book and I looked at the book. I was like, this is easy. I could actually teach from the book. And yeah, this is what you guys got. And I believe that you guys had a fantastic, proper Bosch experience.